In part C, we have 2m plus radical m equals 15. This guy is not a polynomial. Why not? The radical around, you could have like a radical 2 as a coefficient. That's no problem. But it's the radical around an unknown that makes it not a polynomial. Okay, so you can't divide unknowns. You can't have like m divided by y or m divided by n and expect it to be a polynomial. A polynomial is a very well behaved formula. So you only have whole numbered exponents. That's another way to think of it. That square root of m is really m to the 1/2, right? You're only going to have whole numbered exponents. You're not going to be dividing one unknown by another unknown if it has multivariables. So yeah, it's not a polynomial. But if you do think of it in terms of exponents that are fractions, not that you have to think of it this way, but with my previous explanation, this will help. So I'm going to think of that square root of m as m to the 1/2. Now look. Notice, this exponent is twice as big as this exponent, right? So this exponent is twice as big. 1 is twice 1/2. And there are no other powers of m in sight, right? That's how you recognize, well, this thing's quadratic in form. A substitution will work. And so it's really a lot like the last problem. So the idea is we're going to let u equal the thing, in this case, m to the 1/2, such that when you square it, you get the other thing. How do you like that for technical mathematical language? Okay? You let u equal the thing such that when you square it, you get the other thing. Does that make sense? So in this case, u is equal to m to the 1/2. What happens when you square it? Write it down. So what happens when you square both sides of that little equation? Right? Keep the base, multiply 1/2 times 2 is 1. You get m to the 1 power, which is that guy, right? Or that guy. So it's going to work. The substitution is going to work. It's going to become quadratic when you make that substitution. In fact, what do you get? 2 times m is the same as 2 times u squared. So 2 times that m is the same. Oh, m is u squared. So that's 2 times u squared. If I make the substitution, go right like that. And then, m to the 1/2 is the square root of m. So in other words, u is equal to the square root of m. Substitute that guy right in there. And you get 2u squared plus u equals 15. You didn't have to use the rational exponent, but it helped with it related it to the explanation from the last problem. If you let u equal the square root of m, think of it that way. I'm replacing the square root of m with u. It's a substitution. And then we know that if you square the square root of m, you get m. Oh, so that's squaring the square root of m, that's u squared. So it's a substitute, it's twice, substituting twice, basically. Okay, and then this guy, yeah, we could use the quadratic formula on it, but maybe it'll factor. It's worth a try because even though it's going to be a trial and error factorization, if it factors, it won't take too long. What do I need to do first? Whether I use quadratic formula or factor it, I need to do the same thing. Set it equal to 0. So subtract 15 from both sides, like that. All right, I want you guys to give this a shot. I'm not going to say anything. I don't want you shouting out the answer. See if you can remember how to factor that. Gee, I hope it factors. I don't remember if it does. Anybody have it? What do you got?
2u minus 5u plus 8.
So, I agree. Everybody get that? Check it. Outer multiplication gives you 6u. The inner multiplication gives you minus 5u. Those do combine together to make u. Everybody agree with that? Now, I'm going to show the step that I haven't been showing because it might not be as easy to do in your head. What do you do with both factors? Set them equal to 0. 2u minus 5 equals 0. Or u plus 3 equals 0. If their product equals 0, then One or the other factor equals 0. Now solve both of those. What do you get? Add 5, divide by 2, u equals 5 halves, or the other one, u equals negative 3. So we're done, right? No, we're not done. What do we have to do at this point? Go back and look at your work. What does u really equal? You could think of it either way. U equals m to the 1/2 or square root of m. I don't care which one you back substitute in there. You're going to have to do the same thing to both sides either way. So if you think of u as m to the 1/2, you get m to the 1/2 equals 5 halves for the first equation, or m to the 1/2, so we're back substituting in, u is equal to m to the 1/2 or square root of m, or m to the 1/2 equals negative 3. So for the first equation, m to the 1/2 equals 5 halves. What do you have to do to get m, not m to the 1/2? I mean, this is really the square root of m, right? If that helps, think of it that way instead. What do you do to get rid of the square root? The multiplication is not, I mean, in exponent-wise, yes, you end up doing that. But what are we doing to both sides, big picture-wise? To get rid of the square root, we square, right? So we're going to square both sides. Now, let me erase this extra thing here. We're going to square both sides to get rid of the 1/2 power or get rid of the square root. Same thing. Does everybody see that's the same thing? Because m to the 1/2 is the square root of m. So you're squaring both sides to get rid of the square root or to get rid of the 1/2 exponent. Same thing. And then, Ryan, what you were saying, it's right when you think of it on the left side, m to the 1/2 squared, you multiply 1/2 times 2, you get 1, right? So that's how you were thinking about it. Because it's a law of exponents. When you have an exponent on the inside, exponent on the outside, you multiply. If you think of it as the square root of m, what happens when you square a square root? Goes away. Either way, you get m. And then what's 5 halves squared? 25/4. Now, m to the 1/2 equals negative 3. Okay, I think it'll help you to really make the replacement m to the 1/2 with square root of m. It's the same thing, right? Do you ever get a negative number when you take the square root of a number? Have you ever known that to happen? No. So you know that, right? You take the square root of a number, you're not going to get a negative number popping out. So guess what? This is going to be an extraneous solution. Now, if you squared both sides, you would get m equals 9, right? If you squared both sides, it won't check. 9 will not check in the equation. But you can stop here because this can't happen. This is extraneous. But if you didn't think of that, what you would have to do is you'd square both sides, get m equals 9, and then make sure you check your answer. It won't check. Try plugging 9 in there. You're not going to get 15 if you do that. Think about it. You get 2 times 9 is 18, plus 3 is not going to be 15. It's not going to work. So we get just one answer here, 25/4.